So our first speaker for tonight is Jan, who's going to be speaking to us about Elm interreactor, clickable compiler messages for the lazy. So please join me in welcoming Jan. Thank you, Jan.
Hey, thank you. I have another.
Yeah, Jan! Go Jan!
I have extended the audience a little bit. Thank you all for joining me, for taking the time to having me present my little tool to you, which is called Elm interreactor, which is an interactive Elm reactor, and itself saved me quite a lot of time, especially refactoring rather big projects. And I'm gonna go into my little Google Slides presentation that I totally didn't prepare last minute. Here we go. Where's the play button? I think here, slideshow. So you all know about the title. So I quite often work on rather big code bases. I know that many of you are working on things that are closer to the 100K, but for me, I often go beyond the 20,000 lines of code. So it's beyond hobby projects. It's things that are at least supposed to go to production. And the way that I work is that I'm a terminal nut. So I have multiple windows open. I have the compiler on the left-hand side, or rather the browser, and I just read the browser messages, and then I switch over and I try to identify which file I'm in and which line I'm in. For example, right now we have a problem in the main.elm on line 934, and coincidentally I only have the message.elm and toast.elm open, so the error that I need to fix isn't anywhere to be seen. But the general idea is I read the error message, go to line 934, and then fix the import, and then, or the qualified identifier in this case, and then the error message disappears, and I go back to the browser and look at the next error message. And I was wondering if this find line, fix, repeat workflow can be done any better. And this is why I built Elm interreactor, because I'm lazy, and I was thinking, why do I have to, just for simple spelling mistakes, for example, always go to my terminal and copy things over from the browser, the suggestions, or type them out, or manually add the imports. I'm sure many of you are using very powerful IDEs or have like the Elm language server configured, but that's not the case for me. I like to keep my environment fairly lean, and I just look at the browser to fix my messages. And I want to jump straight into the demo of me refactoring the Elm to-do MVC a little bit. And oh, I think Alexa just tried to talk to me. Okay, so so let's go to the Elm to-do MVC, and we will start by starting the interreactor. So you can find it under @func-team/Elm interreactor, and the latest version is 006, which was published 25 minutes ago. And what will happen, it will spin up a local server, and that runs the compiler in the background, and at the same time syncs to the UI. And then we can open this little link here, and we can see, oh, it's compiled, it's all good. So we can now start refactoring the to-do MVC. So what we will do is we will just factor out the message from the main file. So we have the main module, and we will go ahead and find the message type and move it to a new module. And now we can see, oh, it's already complaining. Okay, and now the first thing I'm going to do is I will try to fix all the type annotations. And for this, I will select a space, and then the messages up front. In front, I have 19 selections in my file right now in total, and I would just do message.message. Now the type annotations have been fixed, and now they haven't been fixed, but they have been qualified to the new module. So I really like to use qualified imports. I hardly alias my imports, so that makes refactoring using just plain text search really, really easy for me. And now we can see that the compiler has said, has told me that he can't find, or they can't find a message import, but some names seem close. And you can see that as I'm moving my cursor over these text here, we get some hover effects. And it's unlikely that we will need string. In fact, the problem really is that the message import cannot be found. So I click message import, and let's go up to the top of the file to see what's happening. I click message import, and my text editor told me that a change has been made from outside. So the server has actually just written the fix back to the file. And when I hit Y, you will see that the import message has just magically appeared. So, and it gets even more lazy. Now, I literally just keep my cursor in one point and roughly monitor what I'm doing here. So now all I have to do is I have to click, 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 and it would slowly add the qualifiers to all of the things that have the qualifier, or rather the module name, missing. Okay, keep on doing that. It's failing here on a couple of places with these really short identifiers. So I have to go there and do it manually. So I go to line 225, add. On line 108, we have message.noop and message.add. I save. Update field. Okay, we can go back to just clicking, 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 clicking. And we can see that up here, there's this little progress bar which shrinks for all the errors that are in the current module, as well as a few triangles that will be displayed up here for all the modules that are broken. So it kind of keeps you focused on the goal of fixing or like finishing this really big refactor, because we all know Elm doesn't really do anything for us. Well, it does a lot for us, but it doesn't give us any visible results in the UI unless we fix all the compiler messages. So this little progress bar up here really helps me get focused and see how much work I have ahead of me, and maybe also determine whether I have to take a break or something. And so I'm going to fix the remaining three errors, sorry, here. And then there's one on line 141 that needs manual fixing. Okay, and now it's compiled, and inside the README, we have the build instructions. I will execute the build instructions and open the index.html. And we have the to-dos application running, but based on the new refactored code base. And this is really the gist and most of the things that Elm interreactor supports right now, because it's very alpha and it just been hacked together a while ago, but it's already proven a lot of value for me. So it probably saved me days of work already, just because I could be more lazy. And yeah, let's jump back to the slides. And what's the differences to an IDE? So first of all, it's more accessible. So you don't have to have WebStorm or VS Code and a plugin installed and a language server running, which can sometimes be a hassle to set up. And it's also zero config. So you literally just go there and run Elm interreactor, except if your file is not source/main.elm, you have to define an environment variable that Elm interreactor will use as your main entry point. And the last thing is that the errors come to you. So even when you're using an IDE, usually you have to go to the errors in the file. You have to identify them in your sidebar, scroll there, hover over it, and then apply the fix, which in our case happens automatically. And what's working, literally everything you've seen in the demo. Other things are still broken. So for example, updating the name of fields in records, like making them match or making your structure, the structure of your types or the structure of your data line up. That's something that doesn't work yet, but adding missing imports and fixing spelling mistakes already saves a lot of time for me. So these are the two things that are working. And I also want to go into related work that's out there. I'm sure many of you have seen Elm Pair. which has been released by Jasper Vodenberg recently, but it's a NeoVim integration, which is why I'm not using it at the moment. But this project also looks super promising and actually had a new release only 2 hours ago, and it works like a pair programmer for Elm as well. But it's written in Rust, whereas Elm interreactor is written completely in Elm and a little bit of JavaScript. And then Martin built Elm ID, which is like GHC ID, which I assume I haven't actually used it as a little environment or a little reporter for Haskell errors. And it provides collapsible error messages, but it doesn't yet provide, and I think probably in the future, it won't provide the functionality of fixing problems for you. And the last thing that I want to go into is the perspectives, and I'm actually looking for input here. So there's different sources of errors that we could look at, analyze, and propose fixes for. So one is additionally would be Elm Review, but Elm Review already provides a pretty good way to fix errors for you in many cases, but in many cases doesn't provide automatic fixes yet, because you have to actually make a decision how to resolve the problem. And another thing is the current approach that I have is quite limited because I'm literally just parsing strings, and error reporting of JSON from the Elm compiler isn't super low level. So I think there must be more information that I can get out of the Elm compiler rather than, guessing from the string what is supposed to happen here. These are the two sources that I'm considering extending. And then on the other end, applying errors would be also through Elm Review, for example, or using Elm syntax. But I've had some problems with Elm syntax when I was authoring the first version of Elm interreactor. And Martin always nudges me. I know it wasn't Martin. I think actually it was Razi. So it was Kolya that suggested using language server protocol. And also Martin suggested it to me. And actually I have no idea about language server protocol. So this is something that I really need some input on, or need to do more research on. So that's roughly on the timeline. Or using more manual string interpolation, but I don't really think that's desired because it just doesn't scale so well and is often prone to being incorrect. And yeah, that's about it. And I'm now ready to answer any questions that you have. And also, I'm happy to take input if you have any.
So before we dive into questions, please just join me quickly in thanking Jan for his talk. Thank you, Jan.
Yeah.
Okay, feel free to dive in, Martin.
Okay, my question is, you showed that compiler loading bar, and it showed how many modules were left, if I saw correctly?
Yes. So often you have, let's say, module errors across 5 modules, and each of these modules has a different number of errors. So the top module displays how many errors it has left, or like on the top of each module, you see how many errors are left in this particular module, but you also see the total number. So the triangles are the number of modules that have errored out, and the circles are the number of errors in the module that we're currently looking at.
Okay, I was curious because as I understand it, the compiler won't give you all the errors. It will like search for some of the errors and at some point stop. So
Yes.
Are you somehow figuring out a way to get all the errors, or okay? So it's an optimistic estimate because there might be more after you fix the first batch.
You first have to usually work through parsing errors, import errors, and then you go to the type errors. So it doesn't like go in the future. It's really right now just naively parsing the JSON that comes out of the compiler.
Okay, cool.
James?
Jan, where do we get it?
You can go to functeam/Elm interreactor. I will post the link actually.
Ah, very good, thanks.
Functeam here. That's my part little startup, Funk. You might have seen it before, but I still have this module published there. So you should be able to just run it with npx Elm interreactor.
Yeah. Excellent.
npx at functeam func minus team / Elm minus interreactor. You'll see the instructions
Very
in the
good.
README.
Yeah, this is great.
I have a question.
Sure.
Do you have any thoughts about like helping to narrow valid guesses? Like, for example, with those imports, if there are 5 suggestions that the Elm compiler has, but only one of them would make it compile, would that be compatible with this approach at all?
I think it would make sense to actually write heuristics that rank the suggestions more appropriately. I don't think that the way the compiler is presenting error messages right now is necessarily perfect. I think that's why I said it makes sense to maybe extend the compiler or provide a more low-level API that outputs richer JSON. And you could see that, for example, for the no-op and the add message types, there was actually no valid proposal. So I assume that the compiler is just truncating or like slicing the top 4 items from the list using some type of string similarity and then proposing it to you. But I think there's many more things that can be used to propose changes.
Right. Okay. So is your vision that you're saying that you could get more sophisticated information from the compiler potentially? So you're envisioning potentially trying to get like type information or internals information from the compiler in some way, possibly in the future?
First of all, it really would be a longer list of suggestions and then running a better string matching algorithm over it or better heuristics. But I can also imagine using Elm syntax to actually see which tokens or which tokens are available in a file and would be like a better fit for the current problem, because I think one example is when you let me think of an example. I think sometimes the compiler, for example, when you accidentally lowercase a type that should be uppercased, the compiler doesn't give you suggestions at all for that go in the right direction. So one way we could go about here is we could say, okay, whenever a token or something in a case expression isn't found but was written in lowercase, we should go to the module that it was imported from, use Elm syntax to find all of the tokens that actually match the uppercase version of what we just saw, which was failing, and propose that instead of what the compiler was giving us. But perhaps that should be stuff that should be part of the core compiler rather than a layer on top.
Yeah, because Elm syntax gives you, an AST, but it doesn't necessarily give you concepts of like scope and semantics and types and things like that, as I'm sure Martin Janacek can tell you, and many people here, Mario, and people who have dug into the internals, Jeroen. But anyway, trying to get sophisticated type information and all that stuff is challenging. But the Elm compiler does have that information. So like building tooling by directly accessing what the compiler knows is interesting. And forking the compiler is a potential path to really getting all of that information rather than having to like build up all of these semantics of what's in scope and what the types are and stuff. So there are different approaches to solving these problems, but it's interesting figuring out which is the right one for this philosophy.
I don't know if I'm smart enough. All of this different stuff.
Well, you just hack away at something and see what solves the problem.
But really, I think the upper lower casing is something where I see a low hanging fruit, as well as extending the list of suggestions. And then perhaps another thing we could do would be in a fork or maybe in a patch to the core is have an additional flag that's not that doesn't say JSON output, but that that says something like rich JSON, and that leverages the GHC. I think they have like this deriving pragma, what it's called, that allows you to practically encode anything as JSON. And if we put that at the right level and output that as JSON, that would be actually a pretty good. I think this would be a pretty good starting point to provide more powerful suggestions or more useful suggestions even.
Okay,
So
great.
that's it now.
Well, then we might leave it there. So join me once again in thanking Jan for his talk. Thank you very much.